All right, hi students, sorry for the delay there. This video is going to be lecture video number 1 for resonance. Lecture number 2 is posted on the website and available on YouTube, where it goes over the types of resonance that you'll encounter. So let's start off with some definitions. So we have resonance. And resonance is a compound with delocalized electrons. Okay, so a compound that contains delocalized electrons. So what does delocalized electrons look like? This would be electrons that neither belong to a single atom nor are they confined to a bond between two atoms. Okay, so these are delocalized electrons. They neither belong to a single atom, nor are they confined to a bond between two atoms. So what this reveals is that these are electrons shared by 3 or more atoms. All right, and so from this, we can say then, as far as the orbitals they exist in, that delocalized electrons, they move about p orbitals. Okay, we've been doing some discussion the last several days about hybridization and the orbital diagrams and pictures, and so it's important to recognize that with resonance, we're looking for p orbitals. In fact, when we have 3 or more adjacent p orbitals, we call this conjugation. Okay, so when 3 or more p orbitals are adjacent to each other, lined up in the same axis three-dimensionally, we'd say that these p orbitals are conjugated with one another, and so then these delocalized electrons are able to move about those orbitals. So in considering this, we can ask, hey, where have we seen p orbitals already? So where have we seen p orbitals already? We've seen it in 2 places. One of them would be in pi bonds, and the other is in cations or plus charges, specifically a methyl cation. Okay, so here's what I'm talking about. As far as the pi bonds, let's look at benzene as an example. Benzene looks like this. And let me number, I'll say this is carbon 1 and this is carbon 2 for reference. And we see that there is a double bond between 1 and 2. There also exists another benzene structure that looks like this, where I keep my carbons 1 and 2, but instead of there appearing to be a double bond between 1 and 2, it's actually the carbon before 1, or what would be carbon 3 right here. And some of you had asked in class, does it matter which way I draw the double bonds in benzene? And for saying this right now, It doesn't really. Both of these each we would call resonance contributors. Which eventually leads us into a hybrid structure of sorts, where I draw these dashed lines or dots kind of going around representing the locations of the double bonds. And so this is a resonance hybrid. So technically speaking, if we were to look at benzene at an atomic level, we could zoom in at a split-second moment and see this example or perhaps this one. But the resonance hybrid is an average of all the resonance structures. So it's an average of all resonance contributors. Okay. Back up to the top. All right, so there are some rules here that we need to go by before we start out. And I'll indicate these rules so then you can go into lecture video number 2 on resonance to see the examples and types of resonance that we'll encounter. So the rules before starting out. First, keep in mind that only electrons move. These are the delocalized electrons. Atoms do not move. Okay, so only the electrons move. Secondly, only pi electrons and non-bonding electrons move. Okay, so only the pi electrons, those in the p orbitals, and non-bonding electrons move. Now the non-bonding might be, say, in an sp3 orbital, but from the examples that you'll see in the next video, it's either of those two instances of where electrons can move and be delocalized. Third, the number of electrons stays the same. What changes is the position or location of those electrons. And lastly, the fourth rule to keep in mind is that electrons will only move toward sp2 or an sp hybridized atom. Never to an sp3. Okay, and what we mean by that is the sp3 already, for carbon, let's say, has 4 bonds. So remember, sp3 indicates that there are 4 bonds or 4 areas of electron density. So maybe there's a lone pair there. But we can't move electrons towards that side because then we're adding more electrons than it can hold. At this point, go to resonance lecture video number 2 to learn about the 6 types of resonance that you'll encounter, along with some examples. Thanks.